Hi everybody, my name is Philip and I want to quickly introduce our recent work on KalMamba towards efficient probabilistic state space models for RL under uncertainty. So state space models, or SSMs, are ubiquitous in machine learning, and recently a new kind of structured SSMs has emerged. Think about models such as S4 or Mamba. They were introduced as general sequence-to-sequence models and have been shown to rival transformers in many general tasks, for example, in language and in vision. And they do so while being much more computationally efficient, and particularly for long sequences. However, they are also fully deterministic, which means they cannot really capture uncertainties. These kind of uncertainties are crucial when learning models and representations for reinforcement learning, and for that reason in RL we often consider a different class of SSMs, namely probabilistic ones. So in this work, we wanted to look at how we can exploit recent advances in structured SSMs for the kind of probabilistic SSMs we use in reinforcement learning. The solution we present, KalMamba, works as follows. We have a Mamba backbone consisting of a few standard Mamba layers, which learns a locally linear dynamics model given the observations and the actions. Given those models and the original observations, we can then use standard Kalman filtering to compute probabilistic beliefs over the states and use these beliefs as an input for a standard soft actor critic. Here, it turns out, this filtering can be made efficient using the same idea as Mamba, formulate your computations as an associative operation, and then use a parallel scan. Furthermore, we cannot only filter but also smooth, which allows us to use smooth belief state for learning using variational inference with a tight lower bound. In previous work, we showed this bound is particularly good at capturing uncertainties. We have some preliminary experiments where we show that KalMamba can match the performance of other related probabilistic SSMs for RL on tasks for the DeepMind control suite. However, if you look at the runtime comparison on the right, you can see that KalMamba is significantly faster, and its advantage only grows with the increasing sequence lengths. So if you're interested in our work, check out our paper on arXiv or come visit me during the workshop at RLC.